The next type of elimination that we learn is Gaussian-Jordan elimination. It introduces another mathematician who added on to the method that we've already been doing. So now, instead of just getting zeros in the bottom corner, we also get zeros in the top right-hand corner, and we make sure that all of the numbers on the diagonal are ones. If we do that, this is what our final matrix, augmented matrix, would look like, and you'd be like, oh, z is equal to 2, y is equal to -3, x is equal to 5. And it's really nice to have the answer come out directly like that. So our goal is always to have zeros here, ones here. Then this will be the answer for x, and this will be the answer for y. In a 2x2, you will get that 0 first, just like we did in Gaussian elimination. And then you will get, this is easy to get that to be a 1. And then that will be easy to get to be a 0. So let's look at our situation. I have my matrix A here. I am going to take row 2 and make it equal to row 2 minus row 1. Row 1 stays the same. Row 2 minus row 1, 4 minus a -2, 6. 16 minus 10, 6. I got this 0 first. Now I can take row 2 and make it equal to row 2 divided by 6. Row 1 stays the same. Oops. Right? And there's that always double check every time you do a line that your math is right. So we're not making a mistake along the way. Especially my first work. When you do 4 minus -2, you'd be amazed how many of you make mistakes with subtracting a negative. That's like 4 plus 2. Be careful with that. And so in Gaussian elimination, we would be done. Well, we would be close to done. We'd be able to say, I know what y is, and I can plug things backwards and find out what x is. In Gaussian-Jordan elimination, we want to keep going. So we want to now change row 1, and I can make row 1 equal to row 1 plus 2 row 2's. Notice that that will keep this a 1. And row 2 doesn't change. Row 1 plus 2 row 2's, that makes this a 0. And that makes that a 12. And we just can reduce this to what's called row-reduced echelon form. So there's reduced echelon form, which is the 0 in the bottom, and then there's row-reduced echelon form, which is what we have here. Something on your calculator. If I type in this matrix that we had to begin with, second matrix, put it into matrix A, and now I'm going to have 2 rows and 3 columns because it's an augmented matrix. It was 1, -2, 10, 4, 1, 4, 16. 1, 4, 16. And what you can do is you can go to your calculator. So if I go to second matrix and I go over to the math part, I'd already told you that there is a reduced row echelon form and a row echelon form. So if I push row echelon form, of matrix A, it got it to this step for us, which is kind of nice. It gets the bottom number as 0. If I would go to reduced row echelon form of matrix A, it gets us to the final answer. And we know that, oh, y is 1, x is 12. Very nice. So it's another thing that you can use as a tool to check if you got the right answer. This one would be so easy to do with elimination. But we will using Gaussian. This is sometimes frustrating when you see a better way and you're forced to use a certain method. Oh well. I want to make this one a 0 first. So I'm going to take row 2 and make it row 2 minus row 1. Row 1 stays the same. 2 minus 2, 0. 1 minus a negative 1, 2. 5 minus 3, 2. I take row 2 and divide it by 2. Row 1 stays the same. And now I've got a 1 in the bottom. Row 1 equal to row 2 plus row 1. So row 2 won't change. Adding row 2 to row 1, I get 2, 0, 1 plus 3, 4. And finally, I can take row 1 and make it row 1 divided by 2. Row 2 doesn't change. 1, 0, 2. So we know that x is equal to 2 and y is equal to 1. If we write it as a coordinate, our solution is 2, 1. Here's one for you to try. After getting the answer, plug it into your calculator to see if you get the same thing. Have you guys finished the first one? Do a check. You get 2 and 1. Checked it with your calculator. So I'm going to leave the next 3 for you. I'm going to leave this one for you to try on your own. This one requires that we do some switching around and to get your equations with x's and y's. I'll put it on the video here so you can check your answers later if you want, but you can use your calculator as well. This one requires that you multiply things out and do some rearranging, which isn't very hard, but is some extra work to get your answers. And the same thing with the last one, which I don't have an answer for. You're going to have to multiply to get rid of some of the fractions. Okay? Because I want to show you something new. I want to show you what happens if I make this my augmented matrix. Let's see, where did I? Oh, here's my answer. 3, 5, 1, 2, and on this side, 1, 0, 0, 1. Okay? I want you to change the left side to reduced row echelon form and tell me what you get on the right side. Okay? So our goal here, well, not, yeah, our goal is to get 1, 0, 0, 1, and then tell me what numbers are here. All right, so there's our answer. These two got switched. These ones became negative. And the determinant of this one is equal to 1. So you would have had a 1 over 1. And we notice, hey, that's the inverse. And so although we don't have a technique from before for a 3 by 3, we could now put something out in front. I'll make it easy for you. Oh, wait for it. That might be bad. This one might have a determinant of 0. Let's just do that. That one I think will be okay. Ooh. Just wait for it. Let me just think here for a second. I'm going to make this a 1. I'm trying to make the determinant 1 so that hopefully there'll be less fractions. Does that have left have a determinant of 1 right now? No, it has a determinant of 0. No, I want to make this, keep that a 1. Yeah. Now it has a determinant. That's fine. -1 determinant. I think that'll be okay. All right. Now your job is, again, I've already started off quite nicely for you. Oh, and I haven't told you how to make a reduced row echelon form with a 3 by 3. So you're going to have to figure that out. That's your work till the end of class, is we want to get this side to be 1, 1, 1, 0, 0, 0, 0, 0, 0, and then see what's going to be on this side. Okay? Then after you've done that, I'd like you to type this into your calculator as A and find out A inverse. I'll do that right now just to find out if we have nasty fractions or not. And if we have nasty fractions, that's going to be too bad for you. I'll put the answer up for you to check. 1, -3, 1, 0, 2, -1, 0, -1, 1.